Hey, we are in Chapter 8, Lesson 3. Today we're going to be using slopes and intercepts. The objective for today is to learn to use slopes and intercepts to graph linear equations. And remember, linear equations, that just means that it is a straight line. Just like that. So that's what we're going to be doing today. Let's go ahead and move this up a bit. All right. What this says is you can graph a linear equation easily by finding the x-intercept and the y-intercept, okay? So let's talk about x-intercepts and y-intercepts. Now, I'm going to put out this lovely little graph right here. X-intercepts are something that intersect the x-axis. So this right here is called the x-axis. Right here, this is the x-axis. Okay, and if we had a line, make a nice little straight line here, something like this. This is a line. When it intersects, like passes over the x-axis, what that becomes is what's called the x-intercept. Okay, so this is called the x-intercept. Now, let's go ahead and talk about this particular point. What do we notice about this point? Well, it is, if we were to make an ordered pair, it would be 1, 2, 3, 4, 0. Okay, perfect. Now, let's go ahead and look at a different line. I think this line's going to be pink. It's time for some pink glitter. All right, and I'm just going to draw a different line here, and it's going to look something like this. Okay, a very beautiful. Gosh, it just looks so good, that pink glitter. All right, so the x-intercept would be right here. This is the x-intercept right here. It's where the line intersects the x-axis. Now, what's the point here? Well, the point for this one is actually the x part is 1 and the y part is 0. That's interesting. Do you notice anything that is in common between these 2 points? Oh, let's draw another line. Oh, my favorite is this green glitter. I think I'm going to do a kind of like a line like this. Something like that. Yeah. Use my green glitter. Oh, yeah. That looks cool. Okay, make a little line. And what we're trying to identify are the x-intercepts. And where's the x-intercept? It is right here. This is the lovely x-intercept. Now, what point would that be? Well, if we were to make an ordered pair, this point would be -1, -2. The x part is -2, and the y is 0. Let's do one more. I think I'm really just kind of curious to see how this shows up. It is my platinum. Let's see if a platinum line shows up here. Okay, let's see. What do you think? Can you see it or not? I don't think it shows up very well. That's definitely a negatory on the show up. Okay, gotta get a different color. Let's go with, I'm gonna go with orange. Oh, the orange doesn't go over the platinum very well. Whoa, Nelly, this is all over the place. Okay, there we go. That is a platinum orange line. And what do we see the x-intercept is for this one right here, where it intersects the x-axis? That is, what is that? That is -1, -2, -3, -4, -5, -5, 0. So between these 1, 2, 3, 4 lines, what do you notice is in common? what I see is that the y is always 0. And that's exactly right, is that y is always 0. For the x-intercept, whenever you're trying to find the x-intercept, what you always know is that y equals 0. Okay? So that's kind of like the take home with the x-intercept. X-intercept, y equals 0. All right, perfect. I'm going to put that to the side. Now we're going to take out another one. Now we are actually going to talk about the y-intercept. Now the y-intercept is where the graph intercepts the y-axis. So let's go ahead and look at some different lines where that is the case. So let's look at something like this. It's a lovely blue sparkly line. Okay, if we see here, we just talked about how this is the x-intercept because it intercepts the x-axis, but we don't care about that right now. What we're concerned about is the y-intercept, where it intersects the y-axis. And that would be here at this lovely point here, which is the x part for this point is 0. And the y part is -1, -2, -3, -4, -5. That is what the point is. Okay, let's do another one. And like we did last time, we're just trying to see if we can find something that is in common. I think I'm going to use my pink again. And let's just do one like this, just going up this way. These lines are going to be all over the place. Okay, there's my pink line. Now, where is my y-intercept? Well, right here, this is my y-intercept, right here. Now, let's go ahead and write what the ordered pair of this one is. This is, well, the x is 0, and then the y is -1. All right, so yeah, that's the y-intercept. Okay, let's try this again. We are, where are we at? Where'd my ruler go? Okay, here it is. How about something like this, a lovely little line like this. Okay. Where is the y-intercept? Well, the y-intercept is where it intercepts the y-axis, which is right there. And what is that point? That point is, well, x is 0 again. And the y is 1, 2. Okay, and it really doesn't matter where you put this line. If you put it something like this, you draw a line like this. There's something that is always true, and this orange pen just doesn't want to work for me. Oh, there we go. A little better, a little better. Okay. And the y-intercept would be right here. Okay, and what is the point for that? That is x is 0, and the y part is 1, 2, 3, 4, 5, 6. Okay, so what's in common? Well, all of these have a 0. So that's kind of the take home for this. The y-intercept, every single time there is a graph that intersects the y-axis, we know that x is always equal to 0. Okay? Ooh. So whenever there's an x-intercept, y is equal to 0. And whenever there is a y-intercept, x is equal to 0. All right, so let's go ahead and move on. It says you can graph a linear equation easily by finding the x-intercept, where it intercepts the x-axis, and the y-intercept, where it intercepts the y-axis. Okay, the x-intercept of a line is the value of x where the line crosses the x-axis, where y equals 0. And the y-intercept of a line, is the value where y crosses, where the line crosses the y-axis, and that's where x equals 0. So the y-intercept is x equals 0, and the x-intercept is where y equals 0. Okay? And if we just drew a fun little purple line here, you can kind of see how they both go together in a line here. So this right here, what's this called? Yes, this is called my y-intercept. And the point for this, it's when x is 0, it's going to be 0, 1, 2, 3, 4, 5, 6. And then this right here, this is where my x-intercept is. My x-intercept is when a y equals 0. My x is 1, 2, 3, 4, negative 4, and my y is 0. So there you go. Okay, just a little fun fact before we start doing some problems. It is a helpful hint. I love it when they're so helpful. Okay, this says the form ax plus by equals c, where a, b, and c are real numbers, is called the standard form of an equation. Okay, these are just some lovely forms of equations. So whenever you have the x and the y on the same side and you have numbers in front of them, and you have a number off to this, this is called the standard form. It's a lovely just name for calling an equation something. It's the standard form of a linear equation. So you'll see something like this. So something like this would be in standard form. If you had 3x minus 4y equals 10, that's in standard form. There's numbers in front of the x and the y. The x and the y are both on the left side, and a number is on the right side of the equation. Something else, you could have something like this. Negative 2/3 x plus just y equals 17 over 4. This would still be in standard form. You have a real number here. A number in front of y is 1, and it's all equal to something. Now, this is something that would not be in standard form. If you had, let's see here. If you had something like this, y equals 2x minus 3. Well, the x and the y are on different sides of the equation, so this would not be in standard form. That is not in standard form. Another one, you could have something like 2x equals 4y minus 1/3. And the x and the y are on different sides of the equation, so this would not be in standard form either. But these over here would be. So just kind of wanted to put that vocabulary term out there, standard form. Okay, now we're going to go ahead and apply the x-intercept and the y-intercept. Remember the x-intercept? What do we remember? Yes, whenever we're finding the x-intercept, we know that y is equal to 0, and whenever we're finding the y-intercept, we know that x is equal to 0. All right, let's go. Let's do this. Okay. What this states is that we need to find, example 1, we're finding x-intercepts and y-intercepts to graph linear equations. All right, so it says find the x-intercept and the y-intercept of the line 4x minus 3y equals 12. And look, hey, the x and the y are on both sides of the equation, the same side of the equation, and it's equal to a number. So that means this is in standard form. Little fun fact for you. Okay. What this says is use the intercepts to graph the equation. So first we have to find the x-intercept, okay, and the y-intercept, all right? And then we need to use the intercepts to graph the function. So we got to do find the x-intercept, find the y-intercept, and then graph it. All right, we can do that. Now, when I'm reading this problem, remember when we had the x-intercept? Whenever we find the x-intercept, what do we know? We know that whenever there's an x-intercept, y equals 0. So I'm just going to go ahead and put that little note up here. The x-intercept means that y equals 0. And then it says y-intercept. Well, what do we know about the y-intercept? Well, we know that x equals 0, right? Every single time there's a y-intercept on a graph, x equals 0. So I'm going to go ahead and put that up there. X equals 0. That's what we know. The x-intercept, y always equals 0, and for the y-intercept, x always equals 0. Okay. Now, Let's go ahead. What are we going to find first? How about the